Hello everybody, sorry I got a little lost on my screen. Today we're going to go ahead and start our second to last unit. Honestly, it's like our last unit because the very last one we have to do is very quick. So this is the last big unit we need to do. And to be honest, it's not even that big. So let's go ahead and get started. Today is Unit 8. We're starting quadratics and quadratic functions, quadratic equations. Anything with the word quadratic is in this unit. So, yeah. First thing, quadratic function. It's a function that can be written in the form y equals ax squared plus bx plus c. See, this looks like your polynomials. We're going to be using polynomials in here, where a, the first term, isn't equal to 0. Okay? That's what the function looks like. And it's a function because we have a y, we have x's, it's quadratic because it has a degree of 2, all that fun stuff. A parabola is a graph of a quadratic function in a U-shaped curve, and it's symmetric. So a parabola looks like this kind of thing. It's like a U. So when you graph it, it's a U on the graph. You guys have seen a couple of parabolas when we talked about is it a function or not based on the graph. So here's another example. It can go up or down, all that fun stuff. Okay? Now there are 3 forms of writing quadratic equations, which is the equation you get for a function. The first one is standard form, which is the one you guys are most currently using or you just use. Like when you put the polynomial in standard form. So y equals ax squared plus bx plus c. Factored form is when you factor the polynomial. That's why you need it. So I just made up letters. It's like a plus something times, or sorry, not a, x plus something times x plus something. It's when you factor the polynomial and you set it equal to y. Vertex form, this is the honors topic, but I don't think I'm going to show you this until after SOLs, so to make sure we have time. So you don't really need to worry about vertex form, but I'm going to show it to you. Where it looks like this: y equals a times x minus some number squared plus k, where the h and the k is the vertex of that thing. So you guys could practice writing vertex form if you wanted to. You'll learn how to get all this information, but it's not going to be on your unit test. Yeah. Axis of symmetry is the line, the vertical line that splits the curve evenly. So it's the vertical line that goes through the middle of the curve. And it's usually written like it's a vertical line, so you always write it x equals whatever number. The x-coordinate of the vertex is the x-coordinate of that line. So vertex is always on that line because vertex is always in the middle. It is, and let's talk about vertex. So vertex is the lowest point or the minimum, or it's going to be the highest point, which is also called the maximum of the parabola. So when the parabola opens up, and it looks like a U, it's got a lowest point, that's a minimum, and when it goes down, it's got a highest point, like the top of the hill or the bottom of the cup, kind of thing. Characteristics of a parabola. Well, the parent function is just y equals x squared, very similar to the parent function of a linear equation. You just basically lose the rest of it and just keep the x squared part. And it looks like this. Oh, it's supposed to go through these little points, but my curve didn't want to, so kind of pretend it's like that. So here, I'll just move the curve. Those are the points that it makes. So if you want to just draw your parabola within it, you guys can draw that on your thing. Ignore my little U that didn't work. Now, some things to keep in mind, so this can help you when you're having to draw a graph or to match a graph to an equation. If a, which is the coefficient of the first term, is greater than 0, the parabola is going to open up and it will have a minimum. Okay? If a is less than 0, the parabola opens down and has a maximum because it's going to make a hill. Okay? A will not equal 0 because that's one of the things from the original vocab word that said it can't. If a is greater than 1, the parabola is wider, so it'll get fatter compared to the parent function. And if a is less than 1, it'll be thinner, so it'll be a little skinnier than the parent function. Okay? Zeros, just a reminder about zeros, they are the x-intercepts, also known as roots, and solutions. Okay, when you guys are drawing your parabolas, there you can have 1, 2, or 0 zeros for its function. So that means it can cross the x-axis once, twice, or not at all. If it crosses it once, it will be like the vertex, the tip of the hill or the tip of the cup will be touching the x-axis. If it crosses it twice, both legs will cross through the x-axis. And if it doesn't cross it at all, it just won't cross it. It's above or below the x-axis and doesn't cross. Okay, so let's try an example. So we have to graph y equals x squared plus 4x minus 5. Well, the number on your n, your c, that's your constant. That's also your y-intercept. Okay, so that's what you're going to need to graph that. The other things you're going to need to graph are the axis of symmetry. Where is the middle part of the parabola? And the vertex. The axis of symmetry has an equation. X equals negative b over 2a. Okay, so that's where you need to be able to identify your a, b, and c, just like with with the magic x stuff. The vertex is the x. The vertex is a point on the x-axis, on the axis of symmetry. So that means the x that you got from the axis of symmetry is going to be part of your vertex, and then you can use that to plug in here to find the y. So c is your y-intercept. Did I plot that? I think so. -5. So -5 is 1, 2, 3, 4, 5. Of course I didn't plot it. That's not helpful. You should plot it because that'll be helpful. Then I'm going to do my axis of symmetry, which is negative b over 2a. So I need a and b. A is 1, b is 4. So I'm going to plug that in. You get -4 over 2 times 1. So 2 times 1 is just 2. Means I have -4 over 2, and do that division, x equals -2. So that is my axis of symmetry. Yeah, that's the line. So my parabola will curve around this line. The vertex, the x is also -2. So that's what I'm going to plug in to the x's in the equation. So y equals -2 squared plus 4 times -2 minus 5. So I go ahead and do this. I get 4 minus 8 minus 5, do the math, I get y equals -9. So my vertex is -2, -9. So I'm going to plot that. -2, -9 is right here. Of course, it doesn't want to show. Right there. Now, I'm going to need a whole lot more points to graph this. So I'm going to make a table for some other points. So I just make some x's and y's. I'm going to pick my x's and I'm going to pick some x's, and I'm going to pick x's that are on either side of this axis of symmetry. So -5 is on this side, and -3 is on this side. -1, though, is on this side, and so it's +1. So those are the x's I'm just going to plug in, just like I did with the vertex, to find the y's. So when I plug them in, I get -5, 0. I get -3, -8. I get -1, -8, and 1, 0. Now, if you notice, a lot of these y's are repeating, and it's because of that curve. -3 and -1 are both equidistant from this axis of symmetry. They're one x value away. -5 and 1 are both 3 values away. That's why they have the same y's. So that can help you save some time. So now I'm just going to go ahead and plot the points. So I do this, I do this. I do, is that all I did? Yeah, I have 5. So you should have about 5 points to graph, one of them being your vertex. Then, once you plot all your points, you can just draw your curve, and it should be about a U. Try to make it as U-y as possible. So, you guys, so I made a mistake on this. Try on your own. I was supposed to change this. I didn't. You can try this on your own now that you know what to do. Just cover up the top half of the page and try it again on your own. Or you can save it till the end and try it. So make sure you can do it on your own. Okay? But we're just going to go ahead and skip this. So writing an equation from a graph. Find the zeros of the x or the graph and set them equal to x. Then find the equation to equal 0. expressions will be your factors, blah, blah, blah. This is a lot of writing. So, example 2, write an equation of the quadratic function using the graph provided. So, first I'm going to find the zeros, 1 and 3. That's where it's crossing. I'm then going to say, okay, x equals 1, because that's one of the zeros, and x equals 3. I'm going to work backwards and try to get this to equal 0. So I have to subtract 1 from both sides. That gives me x minus 1 equals 0. And I do the same thing here. I'm going to subtract 3 from both sides. I get x minus 3 equals 0. Now the stuff that equals 0, the x minus 1, the x minus 3, those are my factors. Okay? Those are the parts of the binomial. So this is where I was going to show you about the polynomials. You could graph it, find the zeros, and then come up with the factors from there. So, since I know my factors, I can write my equation in factored form. However, most of the time, they're probably going to want you to write it in standard form. So, to write it in standard form, I'm just going to multiply this stuff together. So, x times x, then x times negative 3, then negative 1 times x, and negative 1 times negative 3. And then combine like terms to make sure it's in standard form. So, you're multiplying it back together. Okay? So you guys are going to try this one on your own. I messed up because I didn't give you stuff that had an actual 0. So use zeros, negative 5, and negative 1. Come up with your factors, write your factored form, write your standard form. And that's it. That's really the only thing you guys are trying on your own. We will practice graphing stuff and like being able to draw a graph and all that fun stuff. So let me know if you have any questions and I will be happy to answer them. Okay? Bye-bye. Oh, wait, I keep saying goodbye, but I don't have the recorder here, so. Okay, now bye-bye.